signal goes to our multi-vibrator, no, not that kind, it's this guy here. In February of 1985, so quite recently then, the British Channel 4 series, For Computer Buffs, tried a unique experiment, broadcasting a mysterious piece of computer software via a flashing dot in the corner of your screen. Now, to receive it, you would need to build a special circuit board by buying a magazine which contained the schematics for the PCB. You'd also need to download some special tuning software, and this was actually broadcast as a sound file in an earlier episode that you had to record onto a cassette to play into your Commodore 64, BBC Micro or Sinclair ZX Spectrum. It was a digital treasure hunt with that elusive piece of software as the prize. The only problem is, Puppy Fractic, this computer program was actually cancelled due to poor ratings at the very end of that actual episode, and therefore it's not known if anyone ever downloaded the program, let alone got it working with that circuit board, which means it disappeared into obscurity and nobody knows what that piece of software was. Until today, that is, because we're going to try to reboot it into the present here on Retro Recipes. And it's taken me and Patreon Paul Jacobson 3 years to piece together everything we needed for this project. We've been reaching out to computer magazines, reaching out to software libraries, museums, asking PCBWay to help us build the circuit boards, and raiding TV station archive libraries for old footage. So I really hope this works.
And we really do believe we've got it right this time.
Join me now as we try to receive a mysterious computer program sent from the past.
Place the circuit in position when the black dot appears and stand by.
Welcome.
Stand by.
Stand by.
Now, we've seen some other quirky software loading methods, from viewer Nejat loading games via a joystick port with an Arduino here, joystick jockeying anyone, to Messiah's Savior delivering similar thrills. The Corzine soft strip, much like today's QR codes, packed more data than a QR code could ever dream of. And recently, Ashton's Retro Computer Room broadcast software over TikTok, and he ended up being nabbed for piracy by time-traveling cops from 1985. Time flies, but the law remembers. Probably. But then there's the German Video DAT system, which broadcasts software right alongside TV shows to Atari STs and such like, a bit like how Teletext in the UK snuck info into our television signals there. Paul Jacobson even managed to miniaturize software tapes to dictaphone size, so you can make your Jet Set Willy even smaller. Speaking of shrinking things though, today we download massive games in minutes. But have we really evolved from 1985 in this project? Back then, in our experiment, software was a flashing light in a black circle on your screen. Essentially, that's all fiber optic cables are doing now today. Flashing light in a black tube. It's just so fast, you can't see the flashing. And of course, part of the purpose of those solutions is to stop you having to arduously handle or type in those programs from magazines yourself. So what of that show? Well, in 1985, the UK's newest channel, Channel 4, introduced For Computer Buffs, a show where four, yes, there's a theme here, enthusiastic techies geeked out about early home computing. Picture the A-Team, but with less explosions. Each episode featured tutorials, hardware reviews, interviews, hands-on demos, and all that kind of stuff that made nerd hearts like mine flutter. Despite its short run, it left a bit of a lasting impression on those who remember the beep-boop magic of the earliest computers and are nostalgic for the days when floppies were floppy and a mouse was something you chased out of the kitchen.
Hello. If you're going to take part in our light software transmission, then either have a cassette recorder ready or keep your video running, because at the end of the programme we're going to transmit the tuning and the operating software for the Commodore 64, the BBC and the Spectrum.
So to see how I'm going to record this, let's go behind the scenes of our setup a little bit. This is the laptop that's going to be providing the video file. This is a dog. And what I've got here, if I just restart that, coming out of the HDMI port into this HDMI to composite adapter is the video signal from the TV show. And coming out of the adapter, it's going composite, the yellow plug there, to this TV tuner. And then the left and right stereo, not that it's even in stereo, is coming up to that good old trusty Boots CR375 cassette recorder that I've had since I was a kid. And let's stick with the Boots theme. These are some brand new, old stock, I should say, ferric audio tapes from Boots from the 1980s or 90s. So we'll use one of those, record the audio there, and just for fun, we'll watch the TV show while we record on my actual childhood TV that was connected to my original Commodore 64 on this very desk. Yeah, we really are time traveling today back to 1985, aren't we?
So if you're standing by with your recorders, we suggest you start them now.
Well, although I'm not sure how to receive that ZX Spectrum software, one thing I do know is the tape recording at least has worked. However, full disclosure, I'll be gobsmacked if we can actually play it back into the Commodore. Press play on tape. That surviving footage is compressed worse than my 90s drainpipe jeans were. And audio compression kills frequencies we can't hear, but that the Commodore desperately needs. Press play on tape. And squiggle. Oh dear. It definitely recognises that there is software trying to come in, but it just can't capture it. But back in 1985, Jane Ashton's powers of predictive telepathy were obviously quite strong, as she said this.
If you have difficulty loading the program, don't worry, because you can find listings of the programs in the March edition of Personal Computer World.
And of course, we have a copy here. Flicking through it, got schematics, and there, receive a program for the Commodore 64 and the tuning program. That's going to allow us to tune our light sucker to our specific TV here. Is that an A or an N? This was much easier when I was 12. Cut this out. Nobody needs to see that I've printed a huge version of the A equals 49152. God, this brings back memories, just tapping in code. May as well make use of my childhood ruler. Calculated ruler. Right, that's everything typed in. Now I'm gonna try and proofread it, make sure it looks correct. Can't quite believe this, but I didn't make a single mistake. Anyway, before we do anything else, let's save our data to disk. So now I typed run, and that's loaded all the data to memory. So now I can call sys49152. Oh my gosh, this is cool. Adjust resistance until the star disappears. Oh, so it gives you a dot to put the sucker on. Good. Well, with that ready to go, we need to build the PCB using these schematics in order to tune it. Let's go do that.
I'm now going to show you what to have to do for the Commodore 64 receiver and the others.
And in order to build that time machine, in the TV show, Dr. Mike Thorne suggests using some Veroboard or strip board and adding all the components listed in the magazine that you can see here. But you know, I've been waiting for an excuse to try out PCBWay's full PCB assembly service. Can they build almost the entire thing for us in the same way that they could build a full retro computer if we wanted? Well, with the help of Patreon Lauren Millsap, we've laid out a full modern incarnation of a directly compatible PCB. Look at this. but it does seem we're missing one crucial component, the 2N5777 phototransistor. That's the all-important part that actually sticks to the TV screen, and I can only find them supposedly on sale in India. Luckily, we think we've found a modern equivalent that should get the job done as well. We'll see. And with that, we upload the Gerber files to PCBWay.com and specify other details for our build. But the fun part comes when we upload our parts list, essentially copied and pasted from a vintage old magazine into a brand new website, and it'll spit the whole thing out at the other end. That's just really cool. And indeed, a few days later, we've got a package from PCBWay. It's nothing to write home about. Now, we did end up with some spares for any supporters that want to try this out. Drop me a message via Patreon or send me a fax and I'll hook you up. And of course, because there are some minimum quantities when they are buying the components in and ordering your PCBs, there are therefore some leftover components. So they kindly provided those here as well. And I'll send those off to any supporters while stocks last. Now, I asked them to leave the phototransistor loose, as we'll need to connect that with a wire and a sucker. Okay, suckers, I know you're as ready as me to grab your flux capacitor and travel back to 1985, one flashing dot at a time, and find out what that elusive program even is. But oftentimes it's important, and in this case fun, to understand the how before seeing the what. So just like Jet Set Willy, I'm going to shrink down for you and travel back to how they did it then. Oh, well this is handy because I can now explain to you how it all works. So things start off with our phototransistor, which is attached to our TV screen over here. Sort of like a digital lighthouse keeper, keeping an eye on when things are flashing on and flashing off. Sort of .communicationsbefore.com. Now the signal is weak, so it needs to be amplified, and that's what these banks of resistors here are going to be doing. They firstly clean up the signal, and then this transistor actually does the amplification of it to make it nice and clean, and, well, I mean, why whisper like a soft-spoken YouTuber when you can shout? Next, the signal goes to our multi-vibrator, no, not that kind, it's this guy here. And this cleans up the signal further and converts it into neat digital pulses, ones and zeros, ready for our computer to receive. Sort of like the Marie Kondo of retro computers. And it outputs those digital pulses, those ones and zeros, over to there, the pinout, sort of like the stage door exit of our PCB. And here inside the computer, the pulses are handled by the CIA, no, not that type, the Complex Interface Adapter chips. They manage data transport from the external ports of the Commodore 64 and act as a sort of digital postman for our pulses. Those are then transferred over to here, to our bank of RAM chips, where they basically hang out and let off steam, waiting for the next step. And that step is this big boy, the 6510 processor, made by MOS Technology, owned by Commodore later in the day, and not owned by Commodore now because they went bankrupt, but we don't like to talk about that. This processor interprets the incoming data from the RAM chips, turning light into lines of code, that is. And it's from here that our program is assembled. And then, of course, it needs to output back to where it all began, our TV screen. And for that, the 6510 processor sends the data to the VIC-2 chip, and that handles the rest of the job. Back to the viewer's eyeballs. It does seem somebody's stolen our PLA. And our SID chip? Well, luckily, I suppose this program doesn't have any sound. Or does it? Actually, we don't know what it is. Let's go and hopefully find out.
You'll need a soldering iron, a few electronic bits and pieces I'll tell you about in a moment, and a spare couple of hours. Now, we're all used to sending software by making little electrons run up and down a wire, but in our experiment it's the turn of the photons. Here's the bit that does the actual light detection. A little phototransistor, just like inside a light pen. Now you'll need to use the receiver together with the receiver program. For the Commodore 64 and BBC Micro, there are just 11 electrical components in the receiver. For the 48K Spectrum, some additional components are necessary because it doesn't have a user port. And the total cost is about £4 for BBC, £5 for Commodore 64 and £8 for Spectrum 48K. The most expensive single item being the plug connecting the receiver to the Micro.
Where do you One of the many annoyances and seemingly mistakes with this project is that they don't actually tell you which pin of the user port to connect to. All you can make out from the screenshot in the TV show is that one of the pins is up there on the top right, but there are 3 pins in total, plus their edge connector has 1 extra pin too many, which doesn't help. But by looking at nothing more than the tuning program code, user TNT has helped us figure out that it looks like it reads pin PB7, which is actually pin L.
Well, the next stage is to add the battery terminals and then 1 variable resistor.
Wait a minute, we don't have a variable resistor, and we must have misread the guide. We only have a fixed position resistor there, which you can't adjust. Hopefully that's not too crucial though.
The variable resistor is crucial because whether the square seems white or black to the receiver board will depend upon the brightness and contrast settings of your TV. So we'll have to adjust that later on to your own particular TV set. And then the user port plug. This one's for the Commodore 64, as is the whole board, in fact. Now on this one we've got all of those, and also I've added the wire which goes out to the photo transistor. Allow a good length for this or you'll regret it later. Right, well that completes all the connections to the main board. First, plug everything in, connect up a battery supply to the receiver. You now put the sticker onto the white square and use a screwdriver to adjust the variable resistor. Pressing the space bar each time, you have to get it so that the star there, this one here, just disappears. There, and then you're all set to receive software transmitted by light.
Only no, we're not. I'm going to save you 5 hours of your life, I'm not exaggerating. I tried absolutely everything, but I couldn't get it to react to the phototransistor. But I kept thinking about the fact that we had to substitute that for a modern part. And so we really need to test if that is seeing the TV screen. And for that, Lauren Millsap suggested using an oscilloscope. I've arranged a little experiment here, an experiment on our experiment. This is the Gochi Fix multimeter, but it's not just a multimeter, it's also an oscilloscope, as you can see. And I've hooked up the 2 prongs to the output of our phototransistor, so we can actually measure if this circuit is working. So right now you can see it's reading quite high, which I assume is what it looks like when it's receiving light. You can test that simply by turning the TV off. We did. We got a flash, but the line didn't move. Yeah, and rather bizarrely, it's just not seeing any differences in the light. That's bizarre, isn't it? Now, rather bizarrely, I just disconnected the 9-volt battery, and now it's responding to light. Yeah, that's no good with 9 volts disconnected. Not doing anything. Yeah, we're still back where we were. And that essentially it flatlines. Now, I kept fiddling around with this for several more hours, but just then, when I thought all hope was lost, a cathode ray glimmer of hope. Interestingly, our asterisk has disappeared for probably the longest it's ever disappeared for, with everything connected. So let's load our receiving program. 49152. Okay, so now that's ready to receive. So we get our show queued up, ready for its flashing dot broadcast, and we'll see if anything comes in.
Five hours later.
Okay, the flashing dot stopped, The big moment, let's run our program. Huh. Well, let's see if there's a program listing. It's still just got the old listing for the receive program in memory. Why is... It's received nothing. Yeah, nothing. Poodoo. And on that cliffhanger, it's almost time for you to turn off your TV too, because like Marty McFly, we're out of time here with our 1985 experiment. But don't worry, the mysterious computer program is far from dead. In fact, it's about to hit 88. Now, important note, subscribing is easier than programming a VCR, so subscribe now or support for early access to join me in the future in Part 2, where Kit undertakes one last mission to help us acquire a crucial component from a crime syndicate, eBay, and all this other retro tech fun, along with the hiccups that only vintage computers could provide. Until then, subscribe below and cheerio.
One man can make a difference, Perry. Or one woman. Or dog. The Fractics, lone curators in a vintage world. The world of retro recipes.